Hello students, I am Dr. Himanshu Sarkar. Welcome to all of you in my YouTube channel. In my last lecture, I discussed the radiation, that is in the chapter of heat in class 11 for CBSE ISC physics. Now I am continuing that lecture, that is the black body radiation. Now I will discuss the black body radiation. Before that, I request to all of you to subscribe my channel so that all of you can view my channel contents. Now in my just last lecture, I discussed the E is equal to what? That chapter is what? Radiation. In radiation, I discussed energy. In radiation means electromagnetic wave, and the energy is connected with the wavelength lambda. That is E is equal to H into nu. Nu is the frequency of the emitted radiation, H is the Planck's constant, and nu is equal to what? Hc by lambda. What is H? H you know, Planck's constant. The value is 6.625 10 to the power minus 34 joule second. All you know, the value of the Planck's constant is what? 6.625 into 10 to the minus 34 joule second. Now C is what? Nu is what? Nu is frequency. Nu is frequency of radiation. Then C is what? Velocity of light. Lambda is what? That is the wavelength. So you know, energy is a function of lambda. So energy depends on lambda. So I discussed in my last lecture also what is the definition of the perfectly black body. Perfectly black body is such a body which can absorb all sorts of radiations falling on it. That is, for a perfectly black body, for a perfectly black body, or in short PBB, perfectly black body in short PBB, you know, A is equal to 1. A is equal to 1 means what? That is the total amount, total absorbed, total energy falls on it is fully absorbed. That is A is equal to 1. But I cannot write down A is equal to 1. A at what wavelength? Because energy is connected with the wavelength. So A, simply what A meaningless. Actually I have to consider A at what value of lambda, and what value of wavelength we are considering absorption, at what value of wavelength we are considering transmission, at what value of wavelength we are considering the reflection. Okay. So I can write down A lambda, that is equal to 1. This for perfectly black body. So now now my first question. So it is clear to all of you that if I consider perfectly black body, it can absorb all sorts of radiations falling on it for a particular value of wavelength lambda. Now the question arises, then if I heat a perfectly black body, what will happen? As it is a perfect absorber, so what will happen? If you heat a perfectly black body, it can give rise to all sorts of radiations. Clear? Also wavelength radiation means for all values of wavelength lambda. I am discussing with a graphical presentation, and this kind of graph is called intensity spectral distribution. Spectral distribution. Black body, perfectly black body, perfectly black body in short, PBB, intensity, spectral distribution. Spectral perfectly black body, intensity, spectral distribution. Spectrum is what? For different values of wavelength. Hence we are using the word spectral. Actually, if a perfectly black body is heated at T Kelvin, if a perfectly black body is heated at T Kelvin, then the graphical expression is that is lambda versus E lambda. If I plot, you can get a curve looking like this. The curve looking like this. Okay. That is the curve looking like this. If at temperature T Kelvin, actually that is the wavelength, the x-axis is the wavelength and this is the energy E lambda. How this graph is plotted? Now first of all, you know energy E is a function of lambda. Now suppose I heat the perfectly black body at temperature T Kelvin, then we are considering lambda versus E lambda. We are measuring like this. This wavelength lambda corresponds to this energy E lambda, wavelength this lambda for E lambda like this. That is, if you heat a perfectly black body at temperature T, you will get this energy E1 at lambda 1, this energy E2 at lambda 2, this energy E3 at lambda 3, and so on. So you are getting this curve, energy E1 at lambda 1. When? If I heat a perfectly black body at temperature T Kelvin, then this energy E1 at wavelength lambda 1, this energy E2 at wavelength lambda 2, energy 3 like this. So the graphical nature is looking like this. This is the value 0. Now, what is E? E means what? E means don't say as a energy. E means energy emitted per second per unit area from a perfectly black body heated at temperature T Kelvin and obviously at a particular value of wavelength lambda. Clear? That is the meaning of E lambda. Again I am discussing E means what? Again I am discussing E means what? E means energy emitted by a perfectly black body heated at temperature T Kelvin per second per unit area and at a E lambda and at a particular wavelength lambda. I think all of you clear. This was very important. E lambda means what? Energy emitted by a perfectly black body heated at temperature T Kelvin per second per area and at a particular wavelength lambda. So the nature of the curve is this. This is experimental result. The lambda versus E lambda curve is looking like this. Okay. Now I am stopping my class here. In my next lecture, I discuss the characteristics of the curve. Thank you.